Hi, today we're going to do number 424, longest repeating character replacement. So we have an input, which is a string, and a k for a number, and we want to return the longest substring that contains the same letter, and we can replace up to 2 times, or k times. So we see in this example, if we replace all the b's with a's, we get a length of 4, and that's what we return. I think a better example is this one. So here, if we replace b with a here, we have a length of 4. Or if we replace a with b here, we'll have a length of 4. And that's what we're going to return. So we can do a brute force way for doing this, where we will have to loop through s. And then inside of this loop is where we want to keep track of the frequency of each one. So we track the frequency, and we can use an array for this, and I'll show you in the code. And then we want to figure out the running max frequency of it. And that's what we're going to update. And when we do this, we need to keep track of the longest as well. And that's what we're going to be returning at the end. So we'll have to track the frequency array and then do this. And with this, we have a frequency char array. So here we're going to have an array of 26 indexes, a length of 26, where each index represents a character code, like A will be 0, B will be 1. And when we see it being used a frequency character, we can increment it to figure out the current frequency. So we're going to do a nested loop here, and then inside of this, we're going to increment frequency with the char value. And with that, we can check if the max frequency is updated with what we had before or the current index values of that array. And now here's where we use this k equals 2 part. So we have to find the window we're looking at as we're iterating through this. So find window, which will be j minus 1, j minus I plus 1, where we do this, the index of this second loop minus the index of the first loop plus 1 to get that index. And once we do that, if the difference, where window minus frequency is greater than k. So if it's greater than the k here, the distance here, we're going to break out of it. So we know we don't want to factor this in as one of the values of the longest. Otherwise, we update longest with max frequency. So if max frequency is higher than it, we update it. Not max frequency, I mean the window, the current window we're looking at. And if that window is higher than it, we update it. So with this way, the time of complexity, since we're doing a nested for loop, is going to be O of n squared, while the space complexity is going to be this constant array of 26 length. So it's going to be O of 1. So a way we can optimize this is that instead of looping through it again, we can have a sliding window of the values we want. So we're gonna keep this left pointer. Not the left pointer, the longest. It starts off as 0, but we're gonna move the max frequency out of it. And then we want a left pointer. And with this, we loop through S. And as we loop through S, we want to figure out, we want to update, when we also need the array outside. So update frequency char with value. And then if the size of the window is bigger than the left side of it, then the K, we decrement the frequency char and increment the left side. So I'll just keep it as there to not go too nitty-gritty, but we're going to have to loop through it and then update this frequency char with the index of it. And then if it's bigger than what we need, we want to continuously remove from the left side until we get to the appropriate ones and update the longest once we get it. So with this way, we can only do a time complexity of O of n, where n is the length of the input, and space complexity is still going to be the same of O of 1, where it's going to be this frequency array. And since this has a better time complexity, we're doing just one loop, we can use the sliding window technique. And I'll show you both ways. So with this way, we create the longest, and that's what we're going to be returning. And then we're going to have to keep track of the characters. So const frequency equals new array of 26 for the 26 characters, and they're all going to have a starting value of 0. And then we're also going to need to know the max frequency of each one, of how often each one's going to be returned. And then we have a left pointer. Now we do iterate through it as with the right pointer. So for let right equals 0, right is less than s dot length, right plus plus. Now here we're going to find the index, const index equals, and we do this trick where we get the string char code at, and the index will be the right, and we just minus by 65. And with that, we can update the frequency array. And now we update the max frequency, because math.max, or what we see in this frequency array. And now here's where we're going to subtract from the left side. So while right minus left plus 1 is greater than k, we want to remove from the left side. So const left index equals, we do the same thing here. And then this, we want to decrement it. And then to move our left pointer along, we just plus it. And then here, we can just do our so here I also forgot, we have to also minus the max frequency to see how many times it appears to narrow the scope of the window. And with this, we can update longest. It can be either the previous longest or the current window we have here. Sorry, this should be the left index. I forgot to update this to left. Great, so now we can do the other way, the brute force way, and we can keep this longest, and we're going to move things inside of the for loop pretty much. So for let I equals 0, I is less than s dot length, I plus plus. And now here we create the frequency, 26.fill. And we do the max count, max freak here. And here we do the nested loop. J equals I, J is less than s dot length, J plus plus. And now with this, we get the index. At J, so we're going to get minus 65. And now we update that in the frequency. And now we update the max frequency. For what we have here. And we see the window size. J minus I here plus 1. And then with this, we have to take into account K. So if window minus the max frequency of how many times it occurs is greater than K, we reached our limit, so we want to break. Otherwise, we want to update the longest with the previous longest or the window. Great, it didn't pass the time limit, but that's another way of doing it. So the key here is that we can use this frequency array to keep track of how many times a character occurs. You can also use map, but with object, but this will have a constant space you're looking at, and then you just get the char code value of it and minus by 65, and then you have to see how many times it occurs, and then you use that to subtract from the window to see how many substitutes you get with the K. If it's greater, we just ignore it. Otherwise, we update the longest. And with the sliding window, we kind of move this nested loop outside to the parent, and we have a running window of it where we automatically increment the values of the frequency as we go up, and then when we hit our limit of being over the amount of k times with the frequency, we just subtract the index of the values from the left pointer to reduce it. And that's all. Thank you.